Hello, Algebra 2 students. Today we're going to look at the test review that I gave you last class period. So, you've already worked through it, and now you're ready to check your answers to see how you did on that review sheet. So, let's go ahead and begin here today with checking our answers. Problem number 1. Let's see here. The first problem here, I look here and I ask myself, what are they wanting us to do? Well, it says here, express the product in simplest form. That means we just need to factor this and simplify it. So let's go ahead and just do that quickly. Now, in doing this problem, it looks like this here is a difference of two squares, so it's going to factor. So it's going to be m minus 6 times m plus 6 all over a 5m times, you have a 6m here, and this does not factor. Why? It's to the m is to the first power, number 1, and number 2, there isn't a common factor between the m and the 6, so I'm going to put m plus 6. Now, what's going to happen from there? Well, from there I see we're going to look and, let's see, m minus 6, do I see one down here? No. M plus a 6, yes, I see one down here. So we're going to divide that out. So, I see this m plus a 6 divides out with that m plus a 6. Is there anything else that divides out? Well, you may look at this and you may say, oh, I see an m there and an m down there. So that's going to divide out. And what do we have left? Well, let's just shove it all together. And when we shove it all together, it gives me 6 times the quantity, m minus a 6, over top of a 5. Now, look at it and ask ourselves, did it ask us to restrict it? And when I look at the directions do not say restrict the domain, so that means we are finito, we are done. Alright, let's move on to the second problem. In looking at the second problem, it tells us, it says multiply the expression in simplest form. Again, we're going to we're going to factor. So I have m minus a 2 and m plus a 2 all over 5m times we have a 4m over m plus 2. Will anything divide out? Well, hopefully you look at that and you see, yes, this m plus 2 divides out with that m plus 2. This m divides out with that m. And we are left with a final answer of 4 times the quantity m minus a 2 all over a 5. And does it want it to restrict it? And it says, no, it doesn't say that. So that means there's our answer. All right, let's go on to question number 3. In question number 3, I have just glancing at it here a little bit, I see division. So what is division? And look at this. I see all sorts of things that I need to factor as well. Now, notice these things over here. That's a y to the first. That's a y to the first. And nothing, there isn't a greatest common factor here, so that one doesn't factor. Okay, but these do. See that y to the second? So we ask ourselves, okay, there's 2 terms. Is there a greatest common factor? Yes, there is. Over here, there's 3 terms. It's a v squared. Is there a greatest common factor? No. All right, what else does it mean? Ooh, I have 3 terms, so I'm going to tree this out to see what factors of negative 12 give us negative 1. All right, so let's go ahead and do it now that we have a plan. Also, it's a division, so that means we're going to apply the KFC, keep, flip, change. So, I am going to write it down, and I'm going to KFC it at the same time. So, I'm going to factor out a v, so it gives me v times the quantity, v plus a 10, on the top over here, and then I'm going to factor this, and what factors of negative 12 give me a negative 1, and that would be negative 4 times 3, so it's going to be v minus 4 and a v plus a 3, and I'm going to change that sign to multiplication, and we're going to flip it, so it's going to be a v minus a 4 over a v plus a 10. Now, let's see, will anything divide out? I have a v plus a 10 up here, v plus a 10 out there, that divides out. I have a v minus 4 up here, v minus 4 down there, that divides out. So let's divide this stuff out. Chunk, 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 chunk. Hey, very good. Is there anything else here? I have just a plain old v, and down here I have a v. Can I divide those out? No, you cannot. Why? Because this is a v plus 3, and this is just a v. So what are we going to do? Well, we're just going to shove it all together and we are finished. What's left on top? We have a v. What's left on the bottom? We have a v plus 3. Now, look at the directions. Does it ask us to restrict it? No, it does not. So guess what? We're done. We've simplified that quotient. For problem number 4, we have another division problem. So let's go ahead and let's see. Let's examine it first. Always look at it. Okay, it looks like I can factor up here. Why? Because that's a squared. And the greatest common factor is going to be u. Look down here. I have 3 terms. Is there a common factor? No, there's not. So it looks like I have to find, since it's a trinomial, I have to find factors of 2 that add up to 3. So in the back of your mind, hopefully you're seeing 1 and 2. And this is to the first power, that's to the first power. There's nothing common between these 2 terms or these 2 terms. And so that will not factor, and I have a division there, so I need to use the KFC principle. Okay, so let's go ahead and factor this out. I'm going to factor out a u, and I'm left with u plus a 1 on top. On the bottom, let's see, it's going to factor into this. What factors of 2 give this? Well, we said 1 and 2, so it's going to be u plus 1 and u plus a 2. Now, I'm going to change this to multiplication, and I'm going to flip the u plus 1 over u plus 2, so it's going to be u plus 2 over a u plus 1. Now, will anything divide out? Well, hopefully you can look at that and you can see, yes, that is true. I see there is a u plus 1 here, divides out with a u plus 1 there. You see a u plus 2 divides out with this u plus 2. And what am I left with? It looks like I just have a u over here left and a u plus 1 over there left. So let's write that down, and we are finito. Okay, so we have u over u plus 1. Now, does it want it to restrict it? Look at the directions. Does it want us to restrict it? It does not say to. So, we're done. All right, moving on to question number 5. Okay, I see it is what? A complex fraction. Okay, so let's go ahead and we're going to write this a little differently. I'm going to write it as a division problem, which is going to eventually become a multiplication problem. So let's see, I have c squared minus 2c minus 24 over top of c squared plus 8c plus 15 divided by, we have c plus 4 over c plus 5. All right, now let's examine this for a second. Okay, c to the first, nothing common, won't factor. C to the first, nothing common, won't factor. C to the second, does it have a common factor? No, it doesn't. That means it's a trinomial. I can tree it out. C to the second, it's a trinomial. Nothing is common. I can tree that out. So I have to think, what are factors of negative 24 that can give me a negative 2? Let's see. What would that be? Could that possibly be negative 6 and 4? Yes, that will work. What about 15? Factors of 15, they'll add up to 8. Well, how about 3 and 5? Okay, so let's copy those down. So let's go ahead and we're going to have a c minus 6 and a c plus 4 over top of. Here it's going to be a c plus a 5 and c plus a 3. Now I'm going to change this to multiplication and we're going to KFC this thing. So it's going to be c plus 5 over c plus 4. Alright, now let's see if we can divide stuff out. What'll divide out? Well, let's see. C plus a 4, whack. That backs off with that. So we divided that off. Is there anything else? Yep, shunk, shunk. We can divide those out as well. And what are we left with? Well, I have a c minus 6 on the top. I have a c plus a 3 on the bottom. So let's go ahead and we'll just write those down. So c minus 6 over c plus a 3. And voila! There is our answer. All right, let's go to number 6, and we're going to do number 6 the same way as we did the last one. So let's walk through it here. And let's see, we have a d squared plus an 8d plus a 15 all over top of d squared minus 3d plus 2. I'm going to put my division sign there. So it's going to be d plus a 5 over d minus a 1. All right, let's factor this thing. And hopefully, and we're also going to KFC it at the same time. So, in factoring, factors of 15 that give us 8. Oh, it looks like going to be a d plus a 5, d plus a 3, all over. Factors of 2 that'll give us negative 3, so that has to be a d minus 2, d minus 1. Now, let's change this to multiplication, and I'm going to put d minus 1 over a d plus a 5. Now, can I divide anything off? Well, let's see if we can. Let me change to my favorite red color, because this is the funnest part of the problem. This whacks off with this. It divides out. What else can I knock out of there? Well, how about the d plus a 5 and the d plus a 5? And I'm left with what? Well, looks like all that's left on top is a d plus a 3 and a d minus 2. And there's our answer. Okay, in question number 7, it's asking us to find the least common denominator. So let's go ahead and find the least common denominator here on this problem. So let's see here. All right, looking here at this one, I need to take this, let's see here. Let me choose what color you feel like. How about green? Okay, so let's take 9x minus 27. That factors into what? How about well, first ask yourself, does it have a common factor? Yes, it does. 9. Factor out of 9. What do you have left? An x minus a 3. All right, now, I'm going to go ahead a step further, and I'm going to change that 9 into 3 squared times x minus 3. Now, I prime factored this whole polynomial right there. Now, let's do the same here. Let's prime factor that one as well. Now, what factors out of 24x minus 72? Well, I can factor out a 24. So if I factor out a 24, I'm left with what left inside? I think it should be x minus a 3. Now let's take that 24, and you might want to do a factor tree on it if you need to. 2 goes into their 12, 2 goes into their 6, 2 goes into their 3. So it looks like there's going to be 1, 2, 3 2's and a 3. So it's going to be 2 to the third times a 3 times an x minus 3. All right, now let's make an inventory of each of these factors. And what do we have? Well, let me change to a different color here. And let's see, I have a factor of 3. I have a factor of x minus 3. I have a factor of 2. That looks like it's pretty good. So I'm going to just write these down here, but I'm going to put the 2 first. Why? Because the 2 is smaller than the 3. And I like to put everything kind of in ascending order. So I'm going to put the 2 right here, and then I'm going to put the 3, and then I'm going to put the x minus 3. Now, let's examine this here for a second here. How many 3 2's do I have? I have 3 2's here, and do I have any 2's here? I do not. So I'm going to take the most. So I'm going to take all 3 of them. All right, now, I have how many 3's here? Well, now this is not a 3, this is an x minus 3. How many 3's here? I have 1. How many 3's here? I have 2. So what's the highest number between 1 and 2? Well, if you said 2, you are correct. Now, let's look here. I have an x minus 3 and x minus 3. I have 1 here and 1 there. So I take 1. Alrighty, and there is my LCM. So let's go ahead and let's clean it up just a little bit. And I can say my final answer is going to be 2 times 2 is 4, 4 times 2 is 8. We have 8, 3 times 3 is 9. That makes a total of 72 x minus a 3. And that is my common denominator. Sorry, not common denominator, my LCM, which is my least common denominator. All right, now we're going to look at another LCD problem, least common denominator. Now remember, on the previous problem, I called it an LCM, and you saw LCD. Now, what is the difference between an LCD and an LCM? Well, LCM is least common multiple, LCD, least common denominator. Okay, so what's the difference? Well, you find the LCM, and the LCM, least common multiple, becomes the least common denominator that you're going to use to get rid of denominators when you have a rational equation. Okay, so that's the difference between an LCD and an LCM. They are kind of the same. Actually, they are the same. But the LCD is used to get rid of common, or should I say to get rid of the denominators for rational equations. Okay, so let's go ahead and now that we got that cleared up, let's go ahead and tackle this problem here. So first of all, in looking at this problem, we need to factor this. Well, is there anything common to both terms? Yes, 9, and you're left with x plus a 1. Okay, is there anything common to this? Yes, a 12, and you can factor out, so it gives you x plus a 1. Now you need to change this into 3 squared because we have to prime factor it in order to see our LCM, or should I say LCD. And that 12 becomes what? 4 times 3, which is 2 squared times 3 times x plus 1. Now, let's write down each of our different factors. I have a 3, I have a 2, and we have a x plus 1. So, let's go ahead and write down each one of those. So, I'm going to put the 2 first, then I'm going to put the 3, and then I'm going to put the x plus 1. Now, let's compare. How many 2's did I have? I had 2. Do I have any 2's over here? No, I don't. So I'm going to take 2 of them. Okay, I have how many 3's here? 1. How many, oops, sorry, I have 2 3's here. I have 1 3 here, so I'm going to take the most, which is 2. And how many x plus 1's here? 1. How many x plus 1's there? 1. So I'm going to take 1. So let's just clean this up a little bit. So it's going to be 2 squared, which is 4. 3 squared, which is 9. 9 times 4 is 36. Times the quantity, x plus a 1. And I said 36. I put 39, so let me fix that up a little bit here. 36 times the quantity, x plus 1. And that is our LCD. Problem number 9, they're asking us to add. To do this problem, first of all, we need to find a common denominator. But in order to find a common denominator, I need to factor. So look at your denominators here. You don't need to factor the numerators, just the denominators. Is there anything that will divide out, or that I can factor out? And the answer is no. But this here is to the first power, so I can't factor that. It's prime. This is to the second power, so are there factors of 2 that give us 3? And the answer to that is yes. So let's go ahead and do that. So we're going to take x over x plus 2 plus, I have a 2x plus 3 over top of, and that's going to factor into x plus 2, x plus 1. Now I need to find my common denominator. Okay, so to find my common denominator, I need the most of each factor. I have an x plus a 2, have 1 here, have 1 here, so I'm going to take the 1. I have an x plus 1, have 1 here. I do not have 1 there. So that means my common denominator here is going to be x plus 2 and x plus a 1. Okay, so x plus 2 and x plus a 1. All right, now let's compare. What's missing here? If I compare here and here, what is missing? Well, if I compare, I see I have an x plus 1 there. I do not have an x plus 1 there. So I need to multiply top and bottom by x plus a 1 on the top and on the bottom. Okay, so in doing that, and I'm going to flip those around because I like the x first. And why can I do that? Well, if you said the community property multiplication, you were right. So now let's compare this here. Am I missing anything over here? Well, let's see. X plus 2, x plus 1, x plus 2, x plus 1. No, I'm not missing anything. So all I'm going to do here is I'm going to bring down this 2x plus a 3. All right, now that I have common denominators, I'm going to add my numerators. So let's go ahead and do that, and let's come right up in this area, right over here. So let's just, okay, so I have, for my denominator, I have x plus a 2, and x plus a 1. In the numerator, I have, and I'm going to go ahead and distribute this in as I write it down. So I have x squared plus x plus a 2x plus a 3. Now I'm going to add like terms. Do I have like terms in here anywhere? Yes, we do. They're right here. So we're going to add these like terms together. And in adding those like terms together, I am going to get x to the second plus a 3x plus a 3 over top of x plus a 2 and an x plus a 1. Alright, now let's examine that numerator. Will it factor? Are there any factors of 3 that add up to be 3? The answer is no to that. So that tells me that I am done. I have added those two rational expressions. Alright, let's take a look at the next one. We're going to do the same thing on the next one here. So looking at this, do I have anything that divides out or factors out? No, I do not have anything that factors out. How about here? It's to the first. Anything common factor there? Nope. Okay, I look here, x to the second. Alright, well, nothing that I do not have a greatest common factor, but do I have factors of 4 that can add up to be -4? Yes, -1 and -3. So let's go ahead and factor that. So I have x over x minus a 1 plus, and then I have 4x plus a 3 over top of, and this becomes an x, what did I say, x minus 1, x minus a 3. Alright, so now let's find a common denominator. What's my common denominator there? Well, it looks to me like it's going to be both of them, so it's going to be x minus 1, because I have 1 here, I have 1 here, so I take 1. And then it's going to be x minus a 3. Notice there I do not have an x minus 3 here. I have 1 here, so I take 1. And over here, let me just copy the same thing down. Alright, now, let's compare. What is missing between this denominator right here and this denominator right here? Well, I don't have an x minus 3. So I'm going to multiply top and bottom by x minus a 3. Alright, there it goes. Alright, and I'm left with an x times x minus 3 on the top. Now, let's compare this. Anything missing here? Anything different? No, there is not. So I'm just going to bring this down. Alright, so on the bottom, I have x minus 1 times x minus a 3 on the top, and I'm going to go ahead and distribute that in as I go. So this is going to be an x squared minus a 3x, and then I'm just going to bring down this 4x plus a 3. And let's come right here and finish it out. So from there, let's see, I'm going to add like terms, and these are my like terms right here. So I have negative 3x plus 4x gives me a 1x, so I have x to the second plus x plus a 3 over top of, we have x minus 1 and x minus 3. Now, can this factor, do I have factors of 3 that'll give me a 1? The answer to that is no. So guess what? I have added those two rational expressions, and I am all done. For problem number 11, let's look here at problem number 11. This time I'm subtracting. So as I subtract, first thing I need to do, can I factor this? No. Can I factor this? Yes. I have a b squared minus 4. What does that look like? Well, I have a perfect square here, a perfect square there, and that's a difference sign. So that's a difference of two perfect squares. Up here, nope, can't factor that. This here, I have a trinomial. Is there a greatest common factor? No. Are there factors of 16 that give me 10? That's a good question. How about 8 and 2? Yes, that gives me 10. So let's go ahead. We have our plan here, so let's go ahead and factor this. So I have a 5v over top of v minus 8 and v plus 8. Subtract 3 over top of v, what is it going to be? V plus a 2 and a v plus an 8. Alright, so there we go. Now, we have to find a common denominator between v minus an 8, v plus an 8, v plus a 2, and v plus an 8. So, what are all the different common Let's think here for a second. Well, let's see. Let's just write down our factors. So I have a v minus 8, I have a v plus 8, and I have a v plus a 2. So in doing that here, let's compare. Alrighty, well, let's see. How many v minus 8s do I have here? I have 1, so I need 1. How many v plus 8s do I have here? 1. How many v plus 8s do I have here? 1, so I need 1. V plus a 2s. How many v plus a 2s do I have here? None of them. How many here? 1 of them, so I need 1 of them. So what I've just found is my common denominator. So let me go ahead and do this with it. And I'm going to write this down here. So v minus an 8, v plus an 8, v plus a 2. Okay, so let's compare what's missing here to there of v plus a 2. So I'm going to multiply top and bottom by v plus a 2. Let me squeeze that v plus a 2 right in there. And on the top here I have 5v times v plus a 2. Alright, now let's compare what's missing here. And I see it's a v minus 8. So I'm going to multiply top and bottom by v minus an 8 up on the top and a v minus 8 in the denominator as well. So I'm left here with a 3 times v minus 8. Alright, now that we have a common denominator, I am going to subtract my numerators. So let's put it all over top of this. V minus 8, v plus an 8, v plus a 2. And on the top I have a 5v times v plus 2 minus 3 times v minus an 8. Alright, so let's simplify that numerator. So I'm going to distribute in my 5v, and I'm going to distribute in my negative 3. Okay, so if I distribute that in, I get 5v to the second plus a 10v. And here, notice you have a negative 3. Distribute the negative with it, so that gives us minus 3v. And then I have plus 24. All over top of this v minus an 8, v plus an 8, and v plus a 2. Now we're going to add like terms. When I add like terms here, well, do I see any like terms? Well, hopefully yes. I see that I have a 10v and a minus 3v. So 10 minus 3, 10, 9, 8, 7 gives me a 7v. So I have a 5v to the second plus a 7v plus a 24 over top of v minus an 8, v plus an 8, and v plus a 2. Alright, and let me go back and grab my green color because I want to finish out that parenthesis there. Okay, now we're going to take a look at these and we're going to see, can I factor that? And looking at that, I just need to just tree it out and factor it and play with it. So what do I see? Well, let's just create a little room over here. So let's scoot this way, and we're going to just see if I can factor this. So I have a 5v to the second plus a 7v plus a 24. So this is going to be 1 times 5, 5 times 1. This one's going to be, how about 3 times 8, 8 times 3, 4 times 6, 6 times 4. Whew, there's a lot of them. We have 2 times 12, 12 times 2, 1 times 24, 24 times 1. Now, do your inside-outside check, and you're looking for factors that give us 7. And if we compare each of those, I'm just quickly glancing to see if I see anything, and guess what? I don't. So that means it does not factor, which tells us what? Well, it tells us this is our difference. Okay, number 12. We're going to go ahead and factor this. So let's see. I have a 3u over, and it's going to be u minus 4, u plus 4, minus, and I have a 5, and it's going to factor down here to be u plus a 4, u plus an 8. Now, looking at to find my common denominator, and we've done enough of these now that I'm going to show a little bit of a shortcut that you could possibly use. If you don't quite follow me, use the same process that I used in question number 11. But most of you in class have realized that if you compare each of this, notice you're missing here a u plus 8. So what you do is you just take that 3u and you put a u plus 8 right there. Alright, now looking here, notice what you're missing from two of these. Well, you're missing a u minus 4. So when you write this down, you're going to go 5 times u plus a, I'm sorry, not plus, but a minus 4. Okay, now in doing that, let's go ahead and let's see, let's just put down, and I'm going to just write one common denominator, and I'm going to just kind of hook these together a little bit like this. So it's going to be u minus a 4, u plus a 4, u plus an 8. Okay, so that's kind of the shortcut most of you have learned to do in class. Just you're combining some steps is what you're doing. And it's saving some paper writing space as well. Now, we're going to add the numerators, but in order to add like terms on the numerators, I have to get rid of the parentheses. So, we're going to distribute in here. So, it looks like right here I'm going to get a 3u to the second plus a 24u. Now, notice that was a negative 5 there. So it's going to be minus 5u, and then I take a negative 5 times negative 4, gives us a positive 20. All over top of this, oops, I put an x, didn't I? Okay. That needs to be fixed, because that was a u. So let me fix this here real quickly here. Alright, so this is going to be u minus a 4, u plus a 4, u plus an 8. Alright, so let's come right up over here, and I'm going to add like terms. So if we're going to add like terms, that's going to give me 3u to the second. And let's see, 24 minus 5, and 24 minus 5 gives us what? 19u plus a 20 all over top of this u minus a 4, u plus a 4, and u plus an 8. And looks like I forgot a parenthesis over here, so let me put that in place there. Alright, now glance at this. Glance at this here a little bit here. What do I need to do from here? Well, ask yourself, can you factor this? Now, I'm going to save us some steps. It doesn't factor. Okay? So since this does not factor, that is going to be our answer. So let's just put a big circle around this, or a cloud, and there's our answer. Okay, problem number 13. Let's look at that one. Oops, looks like I just drew a line here. Alright, so in problem number 13, we have a rational expression over here, with an equal sign in the middle. And what do you do in that situation? Well, we have to identify the LCM, which will become my LCD, and then we're going to multiply both sides by that LCD. So first of all, we have to factor this, and then we have to factor this. Will either of those two things factor? No, it won't. So, because it doesn't factor, now notice something else. Don't be tricked. This is a negative 6n, and you might think this is a negative 6n as well, but it's not. It's a negative 6n plus 5. So, what we're going to do in this case is my LCM is going to be negative 6n times negative 6n plus 5. Now, remember that LCM becomes my LCD. So I am going to multiply that on both sides. So let's go ahead and do that. So I have negative 6n times negative 6n plus 5 times n plus 1 all over negative 6n. And that equals, and then I'm going to have negative 6n times negative 6n plus 5 times n plus 6 all over negative 6n plus 5. Now, look here and ask yourself, does anything divide out? And I see, yes, this divides out. And I see this divides out. And I'm left with, on the left side, I'm left with a negative 6n plus 5 times an n plus 1. And on the other side, I'm left with a negative 6n times n plus a 6. Now, I need to get rid of parentheses, so I'm going to distribute all this. So that's going to give me negative 6n to the second. Okay, that's this times this. Over here gives me minus 6n plus a 5n plus a 5 equals, and I'm distributing here, gives me a negative 6n to the second minus a 36n. Now, I all of a sudden became kind of excited because guess what? When I add this 6n squared to both sides, those subtract out. That means I do not have a quadratic anymore. Which means, now remember what we talked about earlier? Since I have, when you have a quadratic, you have to get everything to one side. But if we just have a linear equation, I need to get all the n's on one side, the numbers on the other, and solve. So that's what we're going to have to do. Alright, so let's go ahead and just do that process here. So, let's see, I have negative 1n plus 5, I'm adding like terms, and negative 36n. I'm going to add 1n to both sides, and I get negative 35n equals to a positive 5. We divide both sides by negative 35, and that gives me n is equal to a negative 1 over 7. Now, we need to take that and plug it in. Make sure it works. So we're going to go up here and plug it in here, 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 and here. And to save us a little time, I'm just going to tell you, it works. Okay, so now that we've established that it works, I'm just going to put my answer in set builder notation. And there is our solution. Okay, let's go on to number 14. And to separate a little bit of these so they don't blend together too much, let me kind of just go a little bit like this. Okay, now for this problem, we're going to do the same thing. I'm going to multiply by the LCD. Now, it turns out the LCD is going to be both of them, this and this. So now I'm going to kind of reduce some steps here, kind of like we did in class. So I'm going to multiply here. I have negative 5p times negative 5p minus 4 times p plus 4 all over top of this negative 5p. And on the other side, I have the same thing. So negative 5p times negative 5p minus 4. And I'm going to run out of room, so I'm just going to kind of squeeze it in here. P minus a 1 all over top of negative 5p minus a 4. All right, now, is there anything that divides out there? Well, let's see. These 5p squared, or these negative 5p's divide out, and these negative 5p minus 4's divide out right there. All right, so let's divide those out. So these divide out, and I'm left with on this side with a negative 5p minus a 4 times p plus a 4 equals And I just saw something that we need to put in place up here. This needs to be an equal right there. All right, and this is going to be up here, negative 5p times p minus 1. Let's get rid of parentheses. So we're going to distribute that in, and it's going to give me a negative 5p to the second minus 20p minus 4p minus 16 equals a negative 5p to the second plus a 5p. And again, I'm going to get excited. Why? Well, hopefully you see as I do, when you add this 5p squared to both sides, they subtract out. That's pretty awesome. So that means I do not have to solve a quadratic equation. I am going to solve a linear equation. So let's see, we can add these like terms together, so that gives us negative 24p minus 16 equals a 5p. So let's see, I'm going to add this 24p to this side, and that will give us negative 16 equals 29p. Wow, that's getting pretty ugly there. So now I'm going to divide both sides by 29, and I will get p equals negative 16 over 29. That is very ugly. All right. Now again, I'm going to save you some time. If you took that, you can plug that into your calculator, and when you plug it into your calculator, you want to plug it in right up here into the p. Check it in with your calculator, make sure it works. I'm going to save us a little bit of effort here and tell you, yes, that is the answer. It does work when you plug it in. On your test, please make sure you check it to make sure it does work, though. All right, so our final answer is going to be p such that p is going to equal negative 16 over 29. And voila, there's our answer. Okay, we have one more left. Now, notice this one is multiple choice. I'm going to let you in on a little secret. For your exam, you're not going to have multiple choice on, well, actually, yes. You're going to have one multiple choice and two non-multiple choice. So make sure you can go all through the steps here. So let's take a look at what's my first step. Well, step number 1 says we need to factor it. Can I factor this? Well, let's look at the top. Nope. Nope. Okay, cannot factor. So step number 2, I need to find the zeros of the function. So I take my numerator, x plus 2, set it equal to 0, and solve it. So I get x equals negative 2. That is my 0. All right, now step number 3. What was step number 3? Well, step number 3, we found a vertical asymptote. So I took the bottom, x plus 1, set it equal to 0, and solved it, and I found my vertical asymptote to be x equals a negative 1. Now, let's look. Is it truly my vertical asymptote, or is it a whole? Well, the way we determine, did any of the factors divide out? No, it didn't. So since they didn't divide out, that meant this was a whole. So step number 4, our horizontal asymptote. So we had to look at the rules here. Now, let's see. Remember, when my p of x is greater than q of x, there is no horizontal asymptote. If p of x is less than q of x, that means my horizontal asymptote is going to be the x-axis, y equals 0. And when the degree of the p of x is the same as the degree of q of x, that means I am going to look at the ratio of my numeric coefficients. So there's a 1 there and the 1 there, so that tells me here that my ratio of my numeric coefficients is going to be 1 over 1, which is 1, which means my horizontal asymptote is going to be y equals to a 1. All right, now let's go ahead and graph this, and in graphing this here, and please make sure you scale, and I'm just going to quickly scale this. There we go. All right, now let's graph this, and let's go to, say, a purple. Let's have some purple asymptotes here. Okay, so first of all, x equals negative 1 is going to be my vertical asymptote. Make sure you label it, x equals negative 1. horizontal asymptote is going to run through here at a y equals 1, so make sure you label it. And now you're going, oh, don't forget, we have our x-intercept, which happened, now let's change to red. So, let's see, x equals -1. Oops, yes, okay, here was my 0 right there. So I'm going to go here and I'm going to label it. Always important to label it. So what's it going to look like? Well, at this point, you plug it into your device. And when you plug it into your device, you're going to see that the graph does something like this. It does not cross the horizontal or the vertical asymptote. And like this. Now remember, sometimes it can cross the horizontal asymptote, but it never crosses the vertical asymptote. And looking at that, there's one more thing we need to look at. What is my domain? Well, your domain in this situation, so let's just put a little d here. Your domain is going to be all x's, all real numbers, such that x is not equal to a -1. So there's my domain. And then, of course, my range. What is my range? Well, my range, we put a y such that, and y is not going to equal my 1. Okay? All right, so that is what you're going to be responsible for. Now, glancing at this, which one of these matches it? And I can look at it and I can say, well, looks like C is the one that matches it. All right, guys, that's going to wrap this up. Your test is next class period. So, study hard. If you missed any of the problems on this review, go back to your textbook, go back to your notes, and study that section a little bit more. Practice some more problems. And if you'd like to, practice this again, then just pull out a sheet of paper and practice it some more. So just be ready and do an awesome job. Again, the test will be next class period. So good luck and happy studying.